Section 3.1, page 2. So let's go ahead and talk about limits. If I was to ask to evaluate the limit as x goes to infinity of 2 to the negative x minus 1 power, first I would rewrite the question without negative exponents so that I've moved my 2 to the negative x to the denominator. Now I'm going to go ahead and actually physically plug infinity in, so therefore I don't have the word limit in front, and I'll have 2 to the infinity power minus 1. Well, we just discussed that if the general shape of this is like a backwards L, then 2 to the infinity power goes to infinity, and we know that 1 over infinity, or any number over infinity, goes to 0. So I really have 0 minus 1, which is minus 1. And I think it's helpful to kind of see that one visually in this case. So we just mentioned that this is the shape of 2 to the x. Because I have a negative exponent, what that does is reflects the graph about the x-axis, although I guess I should be saying the y-axis, right? That we took this and kind of spun it around this way, so it should say the y-axis. Now that I've got this shape, minus 1 is telling me to shift this down 1 unit. And so we knew that we, on the original, would have a horizontal asymptote of 0 over at positive infinity, but because we've shifted it down, 1 down from infinity is negative 1. I said 1 down from infinity, but I meant from 0. Now let's go ahead and actually find some limits. Instead of just plugging infinity in, because that's not going to help me here, what I'm going to do is look to the denominator, and I don't have a variable with the highest exponent, but the variable being in the exponent with the highest term is e to the 2x. So I'm going to divide each term in the numerator by e to the 2x and each term in the denominator by e to the 2x. This allows me to simplify the numerator to just 1, the left side of the denominator to 1, and then there's nothing to simplify on the bottom right. Now that I've divided and simplified, I'm ready to go ahead and plug infinity in. So the word limit is gone. And we know from previous information that we've covered that when we look at this shape to the infinity, it's going to go to a huge number. We really could have written that this was 1 over infinity, which we know to be 0. And so I just have 1 over 1. Example B. Again, I look to the denominator, and the variable only shows up once as e to the 3x. So I'm going to divide the numerator terms by that and the denominator terms. So each term divided by e to the 3x gave me a 1 for the first term in the numerator. In the second term in the numerator, I'm still going to have that 15, but notice when I do e to the 2x divided by e to the 3x, we said we would subtract, but we've got more e to the 3x's in the denominator, so we're going to have 1 e to the 3x remaining in the denominator. Bottom left terms are going to cancel to just give me a 7, and there's no simplification on the bottom right. Now that I have divided and simplified, I'm ready to get rid of my limit by plugging infinity in where there's a variable. And we said this goes to infinity, so 15 over infinity is 0. And what will become 2 over infinity is also 0. So I have a limit of 1/7, which would have been very hard for me to graph with translations. 2 last problems. C, when I look to the denominator, I have an e to the 3x, so I divide numerator and denominator by that. When you divide the first term, you have e to the 5x, hopefully you can see that clearly, divided by 3x. So 3 of these in the bottom are going to subtract with 3 of them on the top to give me an e to the 2x. On the top right, I've got more e to the x's in the denominator, so I'm going to be left with a single e to the x in the denominator. The original question's denominator itself is going to simplify to a 1, and again, nothing to simplify here. Now that I've simplified, I'm ready to take that infinity and plug it in where I've gotten rid of the word limit. We said e to the infinity goes to infinity. Now, if I have 1 over infinity, I get 0 in these cases, and 1 itself didn't cancel. But in the end, I've got infinity over 1, which is infinity. So I still have a limit that's infinity. Go ahead and graph that on Desmos if you want to see the visual. Now, this last example, D, I don't have a denominator, so there's nothing to divide by. So I'll go ahead and plug in the value the limit is going to. Notice in this case, x is going to negative infinity. So I have the negative of negative infinity, which gives me a positive infinity. So it's really just e to the infinity, which we said is infinity.